Hi, future doctors. Welcome to the next class. In this class, we will discuss when two capacitors connected in parallel, what is the common potential, and loss of energy loss. So, how they are going to answer the question? Whenever a capacitor C1 is going to be charged with battery V1, they will give. What is the now charge on this means? Q1 is equal to C1 V1. Now, so they will remove this battery V1. Now again they will connect with another battery. They will connect with another battery V2. So we'll keep this one here and then again we will draw another battery V2 is connected to charge the capacitance C2. What is the charge on this means now? Q2 is equal to C2 V2. Now they will disconnect this V1. They will disconnect this V2. Now these two capacitors they will connected in parallel. C1 and C2. With positive terminals positive, negative terminals negative. Then what is the common potential they will ask? When two capacitors connected in parallel, what will be same? Potential is going to be same. Now what is the common potential? So how we are going to find? According to Ewer's law. What I told you, Ewer's law. Ewer's law is nothing but Q is equal to CV. Now V is equal to Q by C. Now what is the total charge? What is the charge on C1? Q1. So Q1 plus Q2 by how these two connected? Parallel. C1 plus C2. This is nothing but common potential form. This one only they will write in place of Q1 what we will write? C1 V1 plus C2 V2 by C1 plus C2. This is going to be formula of a common potential. This similar equation you will get in collisions common velocity M1 U1 plus M2 U2 by M1 plus M2. In rotation dynamics, common angular velocity I1 omega 1 plus I2 omega 2 by I1 plus I2. This one you will get already in your first year. Now similar equation, this is common potential. Now what happens if positive is connected with negative? So like this if they connect positive, negative, negative, positive. Then this common potential equation will be coming like this. C1 V1 minus C2 V2 by C1 plus C2. This is C1, this is C2. Why they will write minus here? Because polarities changed. Here also you will write minus. If both are moving in same direction, you will write plus here. If both are moving in opposite direction, you will write minus here. So just if you remember this formula obviously you will remember. Next, what is the loss of energy? So loss of energy delta U is nothing but initial minus final or final minus initial. Ui minus Vi. So what is the total initial energy? What is the energy in this case means U1 is equal to of C1 V1 square. In this case, what is the energy means U2 is equal to of C2 V2 square. Therefore, initial total energy U1 plus U2 minus what is the final energy? So in this case, what is the final energy means? Whenever plus and plus connected. So what is the final energy formula? Of Cp V square. What is Cp? C1 plus C2. What is V? This one. C1 V1 plus C2 V2 by C1 plus C2. Therefore, half C1 plus C2 V square development. So if you write fully half C1 V1 square plus of C2 V2 square minus of C1 plus C2 into what is V? C1 V1 plus C2 V2 by C1 plus C2 whole square. Correct? Now you have to expand this. Of C1 V1 square plus of C2 V2 square minus of C1 plus C2. One C1 plus C2 will be cancelled. Then what will be remaining here? So what will be remaining means C1 V1 plus C2 V2 whole square by C1 plus C2. Now take LCM C1 plus C2. Now see here half C1 V1 square into C1 plus C2 plus half C2 V2 square into again C1 plus C2 minus half, if you expand this, C1 square V1 square plus C2 square V2 square plus 2C1 C2 V1 V2. Correct? Now if you multiply all these, you will get half C1 square V1 square plus half C1 C2 V1 square plus half C1 C2 V2 square plus half C2 square V2 square minus, if you expand this with minus sign, half C1 square V1 square half C2 square V2 square. Isn't it? This is A square plus B square. This is C2 square V2 square. So half, if it is cancelled, what will be remaining? Otherwise you can write it half. So minus all these things minus only, half into 2C1 C2 V1 V2 divided by C1 plus C2. Now if you cancel all these terms of C1 V square, C2 square V2 square, if you cancel and if you have taken common, you will get like this. Half is common, C1 C2 by C1 plus C2. What will be remaining here? V1 square, next V2 square. Here you got minus 2 V1 V2, because from all these what we have taken common, C1 C2 C1 C2 C1 C2 half 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 is. So finally you will write this equation of C1 C2 by C1 plus C2 into V1 minus V2 whole square. This is the loss of energy equation. This equation you have to remember. This is when positive is connected with positive. If positive is connected with negative, so what you will get the equation? So delta U is equal to R C1 C2 by C1 plus C2. What you will get here? V1 plus V2 whole square. If positive is connected with negative. If positive is connected with positive, you will get minus. Positive is connected with negative, you will get plus. This is the loss of energy when two capacitors connected in parallel. So whenever they're asking question, you have to see carefully. So both similar capacitors they will give. Whenever they're giving second capacitor is uncharged capacitor, then second capacitor is uncharged capacitor means what is the common potential? If second capacitor, if second capacitor is uncharged, then Q2 is 0. Then you will get common potential C1 V1 by C1 plus C2, because V2 is going to become 0. Isn't it? So this is like in collision, second object is at rest position. So we'll compare with collision, common potential, common velocity, m1 u1 plus m2 u2 by m1 plus m2. Okay, common angular velocity in rotation dynamics, I1 omega 1 plus I2 omega 2 by I1 plus I2. Common potential means C1 V1 plus C2 V2 by C1 plus C2. Here also they will give energy loss, kinetic energy of M1 M2 by M1 plus M2 U1 minus U2 whole square. So this is also rotational kinetic energy loss of I1 I2 by I1 plus I2 omega 1 minus omega 2 whole square. This is now energy loss of C1 C2 by C1 plus C2 V1 minus V2 whole square. Here V1 V2 voltages. U1 U2 velocities. Here omega 1 omega 2 angular velocity. So all these two completed for you in first year. Just I am recalling. So for your easiness to remember, just I am recalling. So like this, if you are comparing, you can remember equations also very easily. I hope you people understood this. So thank you.